Assalamualaikum and a very good day to everyone. I'm Ainaa Aqilah binti HASSAN and I'm from CDCS 2403B. So today, I will be discussing a question based on the chapter 1 of discrete mathematics, which focuses on the fundamental principle of counting. Specifically, I will be explaining the subtopic of permutation with indistinguishable objects. So here is the question. Given the words Malaysia, determine the number of ways to arrange the letters in the word if the first Roman, there is no restriction, the second Roman, all A's are together, and the third Roman, all A's must be together and it must be in the front of the words. So now, let's do the first question, shall we? First, what we should do is count every letter in the Malaysia word. So the total letter in this word is 8, right? So what you would do next is do something like this, so that you can visualize it better and write n equal to 8. If you notice, some of these letters are repeated. To solve the permutation problems with the repeated letters, we first need to count how many times each letter appears in the word, and here is what we will get. Oh, as a reminder to make sure you did all correctly, after you jot down all of this, compare the amount of it with the total letters we just did earlier. Is it the same? If it's the same, then you counted it correctly. Since we are doing the indistinguishable object question, we must use this formula. Since the question 1 Roman asks us to find the number of ways to arrange the letter in the word with no restriction, so basically we just replace the unknown value with the value we just got earlier, and it will become like this. And then use the calculator to calculate this, and the answer you will get is 6,720. So for question 1 Roman, the answers will be 6,720 ways. Now let's move on to the next question, which is this one. When the question asks you all A's are together, it could be together like this or any of this. Since all A's are together, we consider it as 1, and the rest we can start to count it as 2, 3, 4, and so on. Now, by using the same formula as before, this one, you can just replace the value and it will become like this. So where did 3 factorial over 3 factorial come from? The above 3 factorial is the amount of A, and the below 3 factorial is the amount of repetition of A. And then you times it with the 6 factorial over 1 factorial. Now you may use your calculator and you will get the answer for this question is 720 ways. Last but not least, the last question, which is all A's must be together and it must be in the front of the words. Some of you might say, what's the difference between the second question and this one, right? But my love, it is different because in this question it states it must be together, which means it will be fixed. So in this question, it states that it must be at the front, so we do it like this. So now this is where we can differentiate this question with the previous one. This A cannot be counted because it's already fixed, so no need to count it. So you can start to count at here as 1 until 5. So by using the same formula, we enter the values in it, and the answer that we will get is 120 ways. So to conclude, the first question we will get 6,720 ways. The second question we will get 720 ways, and the last question we will get 120 ways. And that's all from me, and with that, thank you so much for listening. Assalamualaikum.